Hello everyone. In this video we are going to know about properties of logarithms. So before we start with the properties, let us refer back to our old friend Ben. Well, Ben's never going to be old because he's a cartoon character, but he's helped us a lot. Okay, so if you want to express the Ben from exponential form to logarithmic form, we can write it down as log of base b of number is equal to exponent, where b is the base, e is the exponent, and n is the number. And as we learned in the previous video, we can easily convert them from one form to other form by simply using the method of pushing the n down and shifting them to the different sides. So let's say n pushes b down, b goes to the other side and pushes e up. So there we see in this case, n goes down, n is here, b goes to the other side, b goes to the other side and raises e to the exponent. So this will help us. So now let's start with the first property. Property 1. What's that? Log of base b of x plus log of base b of y is equal to log base b of xy. So this says that when we have logs in addition with the same base, that's really important. The base should always be same when you try to perform any arithmetic operation on it. So if the bases are same and we add them, they get multiplied into the log. So let's try it with an example. Log of base 10 of 10 square, this is 10, plus log of base 10 of 10 cube is equal to, using a property, log base b of x into y, so 10 square into 10 cube, so that's log base 10 of 10 square into 10 cube. And using the properties of exponents, we can write this down as log of base 10 power 10 plus 10 power 2 plus 3, so that's equal to, we will write it down, log of 10 of 10 raised to 5. So we know that what power should we need to raise 10 to get 10 power 5, that's equal to 5. So just let's write it down as 5. Similarly, to what power should 10 be raised to get 10 square? From here we have 2 and here 3. So that's 2 plus 3 is equal to 5. Okay, great. So let's move on with the second property. So property 2. This is similar to the first one, except that instead of addition we'll be using subtraction with this one. Log base b of x minus log base b of y is equal to log base b x by y. So the only thing to take care of is that the base should always be same. Let's go ahead with an example. Example 2. Alright, so we have been given two values in this. So we have log base 10 of 3 is equal to 0.48. Well, log base 10 is the common log, and if you don't write 10, it still means that the log has a base of 10. So, and log base 10 of 24 is equal to 1.38. And we are supposed to find the value of, let me change the color, there we go, log of base 10 of 8 is equal to what? We're supposed to find this. So what can we do with this property? We know that 8 and 3 are factors of 24. So let's split 24 and see what happens. 24 is equal to 3 into 2 into 2 into 2. That's 8. 3 into 8. So from this we know that 8 is equal to 24 divided by 3. Let's use the same thing here. So this is equal to log base 10 of 24 divided by 3. That's equal to log base 10 of 24 minus log base 10 of 3 using the property. So that is equal to, what's log base 10 of 24? It's 1.38. And what's log base 10 of 3? That's 0.48. So let's subtract them. What do we get? 0.90. So let's check this with a calculator. Okay, there we go. So log base 10 of, what do we need? We need log 8. So that's equal to 0.90309. So that's 0.90. There we go. Let's move on to the third property of logarithm. So this thing says that when log base b of x, where x has a power to it as y, then what we can do is we can send this power out. So which would give us x log b, base b of, this is y, a mistake, this is x. So let's try recall our band. Band says that if b e raised to n, then we can, and we have an exponent to this, to b raised to e. Let's like b e whole power f. So that would be b e into f. Similarly, we can think of this as log as an function that gives us exponents when we put values onto it, right? So log always give us this value when we use. It was represented as log of base b n is equal to e. So log always gives us exponents as the output, right? So this can be thought of as when we have an exponent to an value, they get multiplied, right? So the exponents get multiplied. Similarly, this thing here is an exponent which has a power raised to it. So the powers get multiplied. So we can think of a correlation with this. Let's go to the fourth property, then we'll do some examples. So this thing here, when we have log base x, log base y of x, then we can rewrite this as log base z of x divided by log base z of y. So the only thing to take care of here is the exponents should be, the base that we take, the common base in both of them should be same, and z should not be equal to 1 and z should be greater than 0. So now let's do an example. So we have, let's try to use most of the properties we can use in this example. So log base 4 of x squared into y divided by 3. We are supposed to simplify this, right? So let's go ahead and start doing. So first of all, we can simplify this using the properties of exponents. So this thing, the whole thing here can be written as log base 4 of x squared y upon 3 whole power 1 by 2. So, and from property 3 we can send this ahead here. So that is equal to 1 by 2 log 4 x squared y by 3. This thing doesn't work. Alright, so going ahead, using this, let me just write the properties first so that would be easier. So let's do, so this would now be simpler. Alright, so using the third property here, we can send y, that was the power raised to it in front of the whole logarithmic expression, that is 1 by 2 log base 4 of x squared y divided by 3. So now let's use the second property to separate x squared y and 3. So that would be 1 by 2 log 4 x squared y minus log 4 3. Right, now we can use the first property to split x square and y. Let's do that. So this will be equal to 1 by 2 log x square base 4 plus log 4 base 4 of y minus log base 4 of 3. Now we can again use the property, the third property, to simplify this. That is 1 by 2 log x base 4 plus log base 4 of y minus log base 4 of 3. Here we go. We simplified it as much as possible and hope you enjoyed this video. Thank you for watching.